So, keep in mind in the previous class we said that do not consume that curdled milk if it is curdled by nature, right. By nature means just keeping it for long time outside, then do not take it. Okay. Now, again in this class of dairy and food process and products technology, we are in the lecture 19. So, what are the constituents of milk? We have seen how it is looking, what are the taste, etc., etc. Now, we will come to the constituents of the milk. Okay. That will come and we will see that how acidification and others. Okay. Now, constituents of milk are like this: water, it contains around 80 to 90%, 80 to 90% water, as we have said in some class that depending on the source, depending on the type, depending on the species, this composition varies widely. So, that is why we are saying 80 to 90% roughly. Again it is not that any milk will contain either 80 or 90%, depending on many factors, this varies between that. This is a representative number, right. Small amount of water are also associated in milk as hydration. I hope you have seen in school chemistry that hydrated, right, say copper sulfate hydrated, right. So, that means it contains maybe 2H2O, 5H2O as hydration. So, like that hydrated way, some amount or some very small quantity of water may be also associated as hydration, or they may be bound chemically, right, as maybe to the lactose or maybe to salt or maybe to protein, depending on case by case, right. So, that is how some water is also there. Generally, the water activity, another term which maybe we have said, but if have not, let me also tell here, water activity. This is a parameter by which we tell how much water is available for the organisms to grow. How much water is available for the organisms to grow? By definition, we call it to be water activity as a ratio of vapor pressure of water in the food material at a temperature to that of the pure water at that same temperature. This is the definition of water activity, right. So, milk contains high water activity, because we have seen that it is around 80-90% water. So, its water activity is almost 0.99563 depending on case by case, but it is very high, more than 0.9, right. And if I have said, then could be a repetition, but still better to repeat that water activity, if it is around 0.9 onwards, above rather, water activity varies between say 0.1 or even say 1 to 10, rather 0.1 to 1, it is up to 1, right, or 0 to 1 we can say, though it is not 0, since 0.1 or even lower is that. So, that depends on the ratio of the vapor pressure in the water as well as in the pure water. So, at a temperature, given temperature, so that ratio can be very close to 0. So, that is why it is between 0 to 1. 1 is the maximum, right. So, if it is 0.999 like that, then it is also close to 1. So, anything beyond 0.9, that is good for organisms like bacteria to grow. So, bacteria grows around 0.9 water activity and above. 0.8 water activity and above, is for the yeast to grow. If we classify the organisms in 3 classes, bacteria, yeast and mold. I hope I had said in earlier class bacteria, yeast and mold, and in that case yeast is around 0.8 and mold is around 0.7. So, 0.7 onwards mold can grow, 0.8 onwards yeast can grow, 0.9 onwards bacteria can grow. Obviously, 0.9 not only bacteria, yeast, mold, all 3 can grow, but if it is 0.8 bacteria cannot grow, yeast, mold both can grow. If it is 0.7 then yeast cannot or bacteria cannot grow, only mold can grow. So, if it is less than 0.7 then bacteria, and from the microbiology point of view, typically it is 0.6 because there are some which are even can tolerate at this low water activity of 0.7. So, 0.6 or below is good enough for the elimination of the bacteria or organisms. So, in that case the milk has a very high water activity, that means it is very much susceptible. So, I just said you in the last class that do not take milk if it is curdled just like that, because it is having so much high water activity that not only that curdling organisms, but also many other which may form undesirable end product may also develop and which may be very bad if it is consumed. So, again and again there is very high chance of getting infected by consuming them or by because of the end product which is not desirable, right. So, this is why those organisms may grow in, and that may be some yeast, may be some mold, that may be some bacteria may do something, and you will not be coming to know what is the product which has been developed by the organism, right. So, removal of water as usual increases the shelf life. By and large, we earlier also we have said by removal of water is one of the technique by which we extend the storage life of the food material. In milk also it is like that. Milk powder example, milk powder for example is also highly water highly stable product where the water content is very low, right. Raw milk should not be diluted with addition of water by rule. So, it is that in many cases we have seen that the milkman where if by chance some milk is spilled over or if the demand is high, then those milkmen they do add this water externally, and by law this is adulteration and you should not, you cannot. So, if you come across, protest or do not allow to do that. This is by rule, by law it cannot be added just like that. So, water is one of the major constituent of milk. Then fat, commonly known as butter fat. This fat is commonly known as butter fat, and this fat varies in milk maybe around say 2.5 to 6, that we have seen in the previous earlier classes, that it varies very widely depending on the source, depending on the species, place, for all the purposes it is like there. Oh, I remember when we had given, so I also said that people who are at the high altitude, yes, some animals are there and their fat content is so high that consuming those milk, the young gets lot of energy to fight against the nature of cold, right. So, that is for high fat where, and where this temperature is very high, there that fat content will be very low, because again that digestion for these young will be easier if the fat content is also low in that area, right. So, this is what then protected by a membrane and called fat globule membrane or FGM, right, protected by a membrane called fat globule membrane or FGM. This membrane is generally made of approximately 98% triglycerides, 0.2% to 1% phospholipids and 0.2 to 0.4% sterols, right. Generally not the membrane, this fat is that is milk fat is made of around 98% triglyceride, 0.2 to 1% phospholipids and 0.2 to 0.4% sterols. Different kind of sterols are there, right. Cholesterol is what such which we come across, right. Different types of sterols are also there. These phospholipids and proteins are mostly associated in the FGM, that is fat globule membrane, right. Fat globule membrane contains a lot of protein, some phospholipids, and this is how when we come across with the fat globule, that time you will see that this membrane which is around say plus minus 10 nanometer in size, thick rather plus minus this membrane is around 10 nanometer in thick, and that contains some protein, some phospholipids, some others, some enzymes etc. are also there, right. So, that when we come across with the globule, fat globule, that time we will tell in more in detail. So, this fat or milk fat is termed generally if it is table or light or coffee or single cream, then the fat content is around 18 to 25%. If it is light whipping, that is not less than around 30%. If it is heavy whipping, then it could be around 36%, or if it is plastic or extra heavy cream, then it is around 65 to 80%. By the way, though the milk is normally known as butter fat, butter also do have high concentration of fat or high percentage of fat is around 82 to 83% of fat, right, milk fat, right. That is why this fat or milk fat is also known as butter fat, right. Oh yeah, butter contains around 82.5%, roughly 82 to 83%. Butter oil, which is dry butter, is around 98 to 99.5% fat, 98 to 99% as minimum water as possible there. It is very 98 to 98 point depending on the purity is fat is there, that is the butter oil. By the way, by definition oil and fat they may be the same, but normally from the chemistry point of view we call if fat is solid at room temperature then that is called fat, or if it is liquid at room temperature then that is called oil. So, the difference between fat and oil is that its state, physical state, that is whether it is solid at room temperature or liquid at room temperature, depending on that it is called fat or oil. So, that is why butter is solid, but butter oil is liquid, right. Though the fat content for both are very high, right. So, this is by the by, we are saying by the, not by the by, as an accessory we are saying, right, that the difference between butter and fat is the fat and oil is that fat is solid at room temperature and butter is liquid at room temperature. So, there are many other formulation percentages of fat present in many other milk products. For example, if we look at cheddar cheese, another a variety of cheese that contains around 30 to 40% fat, milk fat, cheddar cheese contains. Ice cream, it also contains around 8 to 20% depending on the ice cream. It varies so widely, fat content is 8 to 20%. Evaporated milk, it contains also fat around 8%, or whole milk normally it contains very high percentage of fat, and whole milk normally we call it to be dried. Now, when it is dried, then it becomes based on dry basis. Hopefully, we also can differentiate between wet basis and dry basis, right. So, whole milk generally powder, so it is said in terms of dry basis, and that is why the percentage of fat is so high, though in the whole or in the wet it may be much lower. And it exists in milk in the form of minute globules, very small globules are there, fat globules. Generally, the globule diameter varies maybe from decimal to up to 25-30 micron in size. The fat globule, obviously the moment we are saying globule, that means it is spherical in shape. That is, in spherical, globule means spherical in shape, right. So, it will have a diameter. So, the diameter is maybe less than 1 to around 25-30 micron in size, right. It varies widely, right. Obviously, the bigger the size, less is the number, and the smaller is the size, more is the number in globules. And subsequently, we will see in one drop it contains around 10 to the power 8 number of fat globules. In one drop of milk contains around 10 to the power 8 number of fat globules, right. So, you imagine, and that is why I said that the bigger the size, small is the number of fat globules, the smaller is the size, more is the number of fat globules in terms of numbers, right. So, in a true it is a true emulsion of oil in water in the dispersed phase. In milk fat, typically in milk, this fat is present as a typical emulsion, where it is fat in or oil in water. There it is not said fat, it is said oil in water, OW. That emulsion is where oil is in the dispersed phase and water is in the continuous phase, because the fat content is very low, maybe around 5, 6, 7%, whereas water content is around 80-90%. So, that is more in quantity. So, it is in the continuous phase, and the other one is in the dispersed phase, that is fat is in the dispersed phase, and the emulsion is called oil in water. Oil is in the dispersed phase and water is in the continuous phase. The reverse, if it is butter, where the fat content is around 80 plus percentage, say around 82%, there it is water is around say 17, 15 to 17% or 17 plus minus percentage of water is there. So, water is much low compared to that of fat. So, there it is called, the emulsion is called water in oil, that is water is in the dispersed phase and oil is in the continuous phase. So, there it is the emulsion of water in oil, right. Each globule of fat is surrounded by a very thin film of protein or the serum of milk concentrated on the surface and held in place by surface attraction or adsorption. As you said that this fat globule or membrane, fat globule do have a membrane, and this membrane is generally around 10 nanometer thick, which we have said. The concentrated layer surrounding by the fat globule is composed of certain protein and fat like substances, especially lecithin, right. In this case, fat is not soluble in water, right, and this fat and water, the relationship we normally jokingly say that the relation between Sas and Bahu, right. Though I am not saying bad or anything, but generally the relation is like that, that none of them can tolerate each other. So, here also that fat and water or oil and water, they cannot tolerate each other, right. That is why you cannot mix oil with water. So, one very good thing that people cannot cannot adulterate oil with water. If oil would have been miscible with water, then we do not know where we would have landed up, right. So, like milk, water could have been freely added to it, but it is not so, right, because oil is not miscible with water. So, what happens? How they are then together? Because if they are not possible, to stay together, then how they are? So, this fellow, what we just said, lecithin, right, especially lecithin, that we said at the end, this lecithin is one mediator. This is one mediator between fat and oil, rather fat and water or oil and water, right. Lecithin is acting as a mediator where it has one hydrophobic and one hydrophilic end. So, one end which is hydrophilic, that is water loving, and another end which is hydrophobic, that is water repelling end. So, this water repelling and water loving ends together is the lecithin. So, the hydrophilic end goes towards the polar end, that is the water, and the hydrophobic end, that is which is going to the oil end or fat end. So, the hydrophobic end couples with the fat end and hydrophilic end couples with the water end. By that way, water and oil are together on the same milk, right. On the same milk, both oil and water are together because of the presence of lecithin, which acts as the mediator, right. So, milk fat contains traces of fatty acids. It contains traces of fatty acids, vitamins A, D, E and K, and lot many enzymes. This milk fat contains traces of fatty acids. Then comes what is fatty acid? Fatty acids are those which can add to glycerol forming glyceride or triglycerides. So, normally by theoretically it is okay HCOOH, that is the formic acid. It is also having a carboxylic acid. So, any carboxylic acid which it is forming with the glyceride with the glycerol, then that could be called a fatty acid. But formic acid is one which is not like that, or the second one, right, that is HCOOH or CH3COOH, that is one membered, two membered. Generally 3 membered or 4 membered onwards, we call it to be fatty acid. 4 membered onwards, it call it to be long chain fatty acid or short chain fatty acid. The more the number of carbon, more is the long chain, and the less the number of carbon, less is the short chain, or it is called short chain, right. Generally it is myristic acid C14, 0 means there is no double bond, palmitic acid C16, no double bond, stearic acid C18, no double bond, oleic acid C18 with one double bond, right. More than, so 400 different fatty acids are there, more than 400 different fatty acids are there, and out of which the predominants are myristic, palmitic, stearic, oleic, all these are, right, they are predominant, but lower number fatty acids are also there, that is C4, C6, C8, C10, C12, they are also present, and we will see subsequently in future class that this lower number, they are volatile fatty acids, whereas the higher numbers, they are non-volatile, right. So, the volatility also depends on the number of carbon atoms present in the chain. If it is short chain, then normally they are volatile. If it is long chain, normally they are non-volatile, right. When we go into detail, then we will also come across. Of course, as I said, as and when we are coming across, normally I am trying to explain so that the understanding becomes much better. Lipids, proteins, cerebrosides, nucleic acids, enzymes, trace elements like minerals, and some bound water stabilize and prevent fat globules from coalescence during milk processing and handling. By the by, since the word has come lipid, here also we must know that there is a difference between lipid and fat. In general, or not in general, it is that all fats are lipids. They are under lipid umbrella, but not all lipids are fats, because there are many lipids which are non-fat, right, where the lipoprotein or glycoprotein, these are many there which are not fat, but they are lipid, right, like lecithin, right, phospholipid. So, this is there, it is not fat. Fats are only the triglycerides or diglycerides or monoglycerides or glycerides of fatty acids with glycerol. Glycerides of fatty acids or glycerides or esters of fatty acids with glycerol. Glycerol is the basic, that is CH2OH, CHOH, CH2OH. So, this OH is adding with acid, and we know acid alcohol, they put together form the ester, and this is called esterification. So, this esterification, if it is single then called mono, if it is double then called di, or if it is all three then called triglyceride. Generally, major portion of the glycerides in milk fat is triglyceride. Okay? We are running short of time now. Thank you.